Okay, I suggest we start now. Good morning in the US, good evening in France, and good evening in Sarajevo. We are here for ICAT 2015 conference, which is many years in execution here. And the topic of today's roundtable will be big data and digital economy. If you don't mind, we start by posing a question, then I will directly asking by name each of you that you give us your opinion, and then we take eventually questions from the audience if you agree, since we are eventually, okay? So, big data is something which is in fashion these days. A lot of people talking about it, but not necessarily defined. So my first question to Jeff Johnson, who is on my left side. So I will ask first Jeff Johnson, then Professor Bauer and then Yassine. What or how would you define big data, Mr. Johnson?
Well, I would say, Kemal, that the issue is not so much that it's big data, but that it's digital data. So I think the game changer in the world is that data are now increasingly digital and therefore available. And certainly there is a huge amount of data, so it is big. But really the game changer is the fact that it's digital and that it's accessible by many people. The definition of big data is because it's digital that's important.
Yes, okay, thank you. And Professor Bauer, what would be your definition of big data?
So, yeah, so big data is really what's important to someone. For some people, big data could be, a few kilobytes or a few thousand bytes or a few gigabytes. For some people, big data is petabytes of data. So it really is the importance. If you look at the big data, you have the issue of velocity, how fast it comes in. You have the issue of volume, how much of it comes in. You have the issue of veracity, whether you believe the data or not. And you have the issue of value of the data, which is really the most important component. And you have the question is only whether, and the variability of the data, how much different data items you have. If the value is satisfied for someone, and it is digital obviously, then it is big data for that particular group of people or person. So that would be my definition.
So I would give it an attempt to answer the question from my perspective, which is the infrastructure perspective. I would say that big data or a data would be qualified as big if we cannot address it, and I will define address later on with the traditional IT systems. And again, this is the viewpoint from an infrastructure perspective. And the reason is that a couple of years ago, we've reached an inflection point where we started to collect and store a huge amount of data. Before that, we were mainly focusing on business transaction data, and this is what was known in this industry as business intelligence. So a couple of gigs, maybe hundreds of gigabytes. And in some industries where transactions were very high, like banking and telco, we started to reach the couple of terabytes. And suddenly what happened is that indeed we reached the inflection point that is amplified by the digital transition. We noticed that anything that we do would leave a digital track. This is also known as the digital exhaust. Okay, a lot of mobile applications, a lot of sensors, and therefore from this inflection point we reached the we started to generate the kind of the famous three V's. First, volume. Okay, volume of structured and unstructured data, and structured data coming mainly from not produced by humans nor by transactional systems, by machine systems, you know, sensor data, and also unstructured data in the form of you know, human text or video or audio. And we have a technological gap. And the technological gap is not only how we process this huge volume of structured data, but also how to make sense of this huge volume of unstructured data. This is the first V. And also the second V, which is variety. And finally, the third one, which is velocity. You know, as data is being ingested, is being produced, sorry, it needs to be ingested, processed, and more importantly, you know, we need to be able to extract useful insight out of it. So, and this will lead me to my conclusion, which is in the form of a big data manifesto, so to speak. I think first item would be to fully harness 100% of the data. Okay, not just getting the data into a given location, but also getting the insight out of it. Okay, whatever the form of this data is. We need to have the appropriate infrastructure deployed and consumed anywhere. We should also be able to scale and get the insights at a speed without any compromise between the two. Okay, scale and speed should be there without compromise. It should be also open, extensible, and easy to adopt, so that you can open it to as many persons as possible and integrate it with as many systems as possible. Last but not least, it should have some economics that work. Okay, and I would say economics that work was also the key trigger that has led us to start considering big data. So that was my kind of first perspective when it comes to a attempt to define big data.
Also by implications on the economy. So yes, it's already being transformed, and there's a long way to go. So you mentioned Europe. In Europe, the European Commission is investing a lot of money in high-performance computing, support developments using big data, and to increase the capacity for developments in big data and for business. So yes, for sure, it's.
So digital economy is, you know, along the lines that I think Yasin already indicated. I distinguish 5 V's for this that I mentioned already, but you know, the velocity, the volume, the variety of data, the veracity, but actually the principal part is how one gets to the value. And digital economy is definitely here, and it needs to basically make use of the digital data to extract knowledge and information and create applications, and for want of a better term, wisdom for the whole thing. And in order for that to happen, you need not only the data, but you also need people, you need technology, you need education, and you need some properties of the systems that handle the data, things like provenance, compliance, security, usability, privacy, preservation, things like that. And in fact, my view is that any industry, any economy that is not capable of handling big data is not educating the workforce to handle data and transformation of big data into usable information. We call data sciences and analytics over here. And unless people are trained to do that, and unless they are poised to do that, then that particular industry or actually academic institution or government institution in economy will have problems. So it's definitely here. It's here to stay, and it's mostly a question of making sure that we actually do get some reasonable value out of all the data that's coming around.
Yeah, as you know, Kemal, this is what we call at HP the new style of business. Okay, and this is actually coming or emerging from a kind of perfect storm that is combining several factors. I would say that first one, and as this has been just mentioned by Professor, is that we need some preconditions, and for those we need hyper-connected workspace and ecosystem. Okay, just to make sure that with anything that we do, we are again leaving some trace, so that we can analyze the data, analyze the experience in order to deliver other type of experiences that are going to create specific outcomes in a personalized manner. I think you've all seen this kind of picture that was circulating in the social media about what's happening in 2015, like Uber, the world's largest taxi company that doesn't own any vehicle. Facebook, the world's most popular media that doesn't create or own any content. Airbnb, the largest accommodation provider without any real estate. And Alibaba, who is the most valuable retailer but has no inventory. Okay, so here I would say that those companies are becoming data companies. They are just using the, or let's say, transforming through the digital world some existing experiences into a new way of consuming the same experience. But as we consume this experience, we are leaving data, okay, because we have to. And by analyzing this data, they start to create new kind of business models, okay? I'm sure you will see that Uber, for instance, is partnering with Carnegie Mellon University in the US and working on the driverless vehicle. Okay, so who knows what may come in the next couple of years. Others are also partnering to create value out of the data that they are collecting. So I would say that indeed we are witnessing a revolution due to the in this digital transition. That the value that will be created will come from first taking an existing experience or process and looking at how to re-engineer and re-deliver this same experience using the newly available ecosystem comprising all of this connectivity and mobility. Capturing data from this new experience and then personalizing first this existing experience and then looking at developing new experiences or creating new business models. And definitely big data is going to play a pivotal role here to be able to move from one experience to another and from one business model to another.
Okay, great. Well, I'm going to focus on a technology which is relevant to my own area of complex systems and policy, which is the concept of a synthetic micropopulation. So in our world in complex systems, one of the most important ways we can have of knowing how systems are going to behave in the future is through simulation. And when we're looking at social systems, we need to have full population, 100% samples, which of course don't exist. And the notion of a synthetic micropopulation, so whatever data exist, and to deaggregate them so that the synthetic micropopulation has the same statistical properties as the data you started with. And here in Genoa, where I am, we're just having a meeting on so-called global system science, where we're talking about big data and complex systems. And certainly here, the notion of the synthetic micropopulation is very important, so that in the US, they have already created a synthetic micropopulation for every person on Earth. It's a new technology which we're still beginning to understand, and the European Commission has just put a lot of money into high-performance computing to support synthetic micropopulations for Europe. So for me, this is one of the most interesting new technological developments, and we will see how this goes.
So the technology obviously has to have a range of and I believe that most of the data and most of the technology will reside in the cloud, and the cloud capabilities will have to range from ordinary sort of service type things to high performance computing, high performance data, places where one can reliably and securely with confidence leave the data and do the computations. But that's the infrastructure. There's always going to be a very important part, which is data buses and data management, which means that one will be able to implement different security models, different privacy models, and actually stay in control of one's data. So one has to be able to really design both the data stores and the data manipulation and data transmissions and everything else so that the data can be given to whoever you want them to give, and to also prevent data leakage in the sense of if I go to many sources, I can actually identify people and do other things. And there are technological ways of doing that. But our present problem with that is actually laws and regulations. I think the regulations are not necessarily friendly to a person owning one's own data anywhere where there might be. And that needs to improve. There's also, of course, a set of software tools. You have to have middleware and device layer data, anywhere from hand devices to supercomputers, that would actually allow you analytics, things like R, SAS, SPSS, much more complex tools that can deal with complex situations, including simulations that, of course, can give you great insights based on whatever is going on right now, and ability to actually visualize that information and, in fact, reduce that information to something that human brain can actually accept and understand in a time period that we need to do that in. Otherwise, just getting overwhelmed by the amounts of data doesn't help. So the technology has to cover the whole stack. It's cloud-based, I think, and it will be having all these additional properties.
I think I've answered this question in my manifesto by mentioning the kind of key requirements for a technology to handle big data. One thing that I would like to add is the view that we can have on the data. Okay, and this is something also that at HP we call the big data balance sheet, in the sense that at the same time data is an asset, it can also be a liability for you. Okay, so an asset in the sense that you can monetize, differentiate, use it to personalize, monitor, optimize, or whatsoever. But at the same time, if you don't handle it correctly, it can become a liability for you. Okay, from a regulation, compliance, control, security perspective. So therefore, when we think about infrastructure, not only we need to be able to handle and process huge amounts of data at speed, at scale, with economics that work, but also we need to make sure that we have also in place the appropriate tools to govern this data and the appropriate set of skills to extract useful insights from it.
Okay, well, in some ways, this is an easy question because it will be both. That we have to learn new ways of doing things. There's clearly a big problem with privacy However, big data is already making life better in many ways, socially, and certainly for me as a scientist, it's making a huge difference. However, I think maybe big data has the possibility to make us more human. One thing we're seeing through all these social networks is that we're beginning to understand what kind of animals we are, that we are social animals, and it's quite possible, and in my opinion desirable, that we might learn how to behave more successfully and more enjoyably offline as well as online.
Oh, absolutely better. I think the world will definitely be better off. We are going through the initial oscillations of learning how to deal with the new technology, with the new information sources, with things which we're not used to when we grew up. But the next generations of children who grow up with all this technology will learn how to live in that world. And I think that that you know the Jeffrey is right in the sense that it might be bad and good things there, but people will learn to get to know each other, and will learn how to not only behave in this big front yard that everybody's close to everybody in the digital space, but also in the world where one will actually be washing the data, but the data will be, in fact, you will be able to privatize the data and keep control over it and know who is using it and not using it. It is just this transition period that we are going through right now that is very disturbing to everybody, and one has a lot of issues. We will learn how to control the security and privacy and everything else, but it takes time. It's not an instantaneous period. But I definitely think we will be much better off by having all that information.
Yeah, so obviously it depends on the application. So big data is a domain. We will have a set of infrastructures, set of applications, set brains and skills. And actually it will depend on what we are going to do with that. It can be good or evil. But in general, I think that this is going to be for the good of the society, specifically if you look at it, at all of the applications in healthcare, and how personalized medicine is developing. Okay, how you can monitor some vital functions for each individual and send it in real time to collect a lot of data and see how the body is reacting to a specific treatment. I think for me this is very positive. Something very simple, as was mentioned by Jeff, is to understand the social behavior. Today we are very active in the social media. Everybody more or less has a phone. Through the phone we know the exact location of individuals. So with all of this data we can have a kind of ground truth data to build simulations to understand how people behave in case of natural disaster, where they are moving. Okay, because we can track their position, or we can try to predict, where another natural disaster is happening, because people are starting to tweet on what's going on in one place, etc., etc. So for me, it will be definitely positive, but there is an effort to be done so that we make sure that the whole world is going to benefit from this transformation. Okay, and here I'm thinking about people in the developing countries that may not have the appropriate infrastructure to also join the revolution.
I can try and answer that. I think the privacy issue, of course, is a problem. Privacy issue has always been a problem in some sense, except the extent of it hasn't been as large as it is right now. Before, if you got on the roof of the house and you shouted some private information, it only went as far as your voice carried. Right now, if you do that, it's all over the world. and obviously that is a bit of a problem. We are learning quite a lot about how to preserve privacy. It's actually possible to do that both theoretically and in practical terms. And in the future, as the technology to do that penetrates further, we will have very good control of our own data. I think the data will be in a variety of places, but we will have both legal and technical means to limit who uses the data and for what it's being used, and you will be informed if somebody is using your data for something else. There will always, of course, be criminals and people who use the data in an unauthorized fashion, but I think as we learn how to deal with this tsunami of information and exposure, we are going to get better, definitely, because one can actually do some of those things already now.
I would just say that I agree with that, that I think that the issues of security and privacy are very demanding, but I think that people are very creative and that we will find solutions to these problems and that we will learn to adapt.
Yeah, interactivity could be defined, I think, as a kind of real-time system with a time scale adapted to the human line of thoughts, meaning that as I'm interacting with the system, I need to get answers as I'm asking questions so that I can keep on having the interaction or the conversation with the system in order either to refine an initial question or to follow up on a kind of specific reasoning. Today we have databases that can handle this type of data at scale. I can mention the one that is provided by HP. It is called Vertica, which is basically no more than an SQL database, very much similar to Postgres from in the sense that it handles a relational model. It is fully SQL compliant. It has only one difference, is that it can handle data starting from hundreds of gigabytes up to a couple of petabytes. One example that we have is with Facebook, who's using it for 4, 5, or 6 petabytes of data, and still being able to have interactive queries with that. So it's a kind of the class of database is called MPP for massively parallel processing. It can scale by adding nodes, from 3 nodes up to hundreds of nodes. But to get back really to your question, I would say that the challenge would be is not necessarily from the infrastructure, because we have this type of infrastructure today, but it would be more in having in place the appropriate data model and populating the data model from the different sources in order for you to get a view on all of the data that is available. If you manage to do that, I would say that from a technology or infrastructure perspective, it would be possible to query this data in a very interactive manner.
Yes. So maybe I can try and answer that. So the answer, you're absolutely right. I mean, the big data in the sense of value has been around for a long time. The volume of that big data and the velocity of that big data may have been different. It is just now that the technology has reached the level where the connectivity of the population that is using devices like smartphones and other devices that are reaching into the data space is pretty much prevalent. It's everywhere. And we have reached the commodity level for storage devices that are very capable. They can, and also there is technology to actually get that information in real time or some other processed time to the consumers. So it's not that big data didn't exist before. It is right now that the volume of that big data is growing extremely rapidly, as is the velocity, the amount of data coming in. And we are actually capable of handling it. Before, we used to ignore a lot of things. You know, there would be a lot of meteorological data and other information coming from all over the world, and it would end up being something like a write-only databases because there was no technology to pull it out fast enough and analyze it. Now we have that. Now we can, for instance, look at the hurricanes or cyclones in real time. We can try and look at the finer granularity of the space, the geospatial analytics, because it's becoming much finer, more finely granular. So it is really the capabilities of technology and of individual users, a broader, much broader range of users have been enabled. That is why it's bringing up to the top. But yes, you're right. It has been around for some time, and really, the value itself is now increasing because one can actually get into more sources and more data and actually refine the models either by collecting data or by more sophisticated simulations of what is happening. So I would like to thank, it's great to meet all of you, and I would like to say it is an honor and a privilege to have been invited to this. Thank you. And I'm looking forward to potentially other interactions with everybody. Thank you very much.
I can add to that. It's been very interesting to hear what everybody else had to say. Thank you very much.
Okay, same here. Thank you very much for the invitation, Kemal, and thanks to the audience.
Okay. Goodbye.